This is problem number 3 for assessment number 6. It says find the areas of the regions enclosed by the following curves. It gives you a x to the fourth minus 4x squared plus 4, so a fourth power polynomial, and it gives you x squared minus 1, which is a quadratic, and it says find the areas between, or the areas of the regions. Now, I think it's important that we at least look at the graph of the two functions real quick. So if you look at the graph here, the red function is our x squared minus 1 function. So y equals x squared minus 1, that's the red function. The blue function is the x to the fourth function, the fourth power function. And you see the fourth power function makes a w, and you can see that it crosses the red function 1, 2, 3, 4 times. 4 different times. And at different points, the red function's larger than the blue function on the left side and the right side. If you notice, it's above it. And then in the middle, the blue function's larger than the red function. So these are important things to kind of be able to picture. And I think most of you should be able to picture the parabola along with a fourth power polynomial. Should be able to picture what those two things look like. Now, we don't actually need the graph to solve this at all. So let's go ahead and start solving this problem. The first thing we need to do is we need to figure out where do they intersect each other, because that's where we're going to find, that's going to be our, basically our endpoints for our integration, right? We're going to integrate from this point to this point, and those 2 points are going to be the roots. So let's go ahead and set these two things equal to each other. So we're going to say x to the fourth minus 4x squared plus 3 equals x squared minus 1. I'm going to solve this, set it equal to 0, so subtract the x squared, x to the fourth minus 5x squared plus 4, when you add the 1 over, equals 0. We're going to factor this. This will be x to the fourth, or no, factor it, we're going to say x squared. This is factorable because we know 4 and 1 can add to 5, so we can do x squared minus 4 and x squared minus 1 equals 0. Negative 4 times negative 1 is obviously 4. Negative 4 times x squared is negative 4x squared, and negative 1 times x squared is negative 1x squared. Add it with the negative 4, you get the negative 5. So you can see that this is how it factors. Now we're going to set x squared minus 4 equals 0 using the zero product property, or x squared minus 1 equals 0. So x squared equals 4, or x squared equals 1. Square root x is going to equal plus and minus 2, or x is going to equal plus and minus 1. Now these are the roots. So this is where our fourth degree polynomial intersects with our quadratic. I want to draw a number line here, and I want to label these from the smallest x value, so negative 2, to the next smallest, which is negative 1, to the next smallest, which is 1, then to 2. Now I'm trying to find the area between the two curves. Well, between the two curves occurs between the roots. So from negative 2 to negative 1, from negative 1 to 1, and from 1 to 2. However, we looked at the graph, and we noticed that between negative 2 and negative 1, we had one function that was larger than the other function. That was the same on this side, but in the middle, they flopped, right? The other function was larger than they flopped. The functions, one function that was largest now became smallest. So let's say if we didn't graph this, how would we figure this out? Well, if we didn't graph it, how we'd figure it out is we would plug in some numbers. And I labeled that this would be like the f function and this would be the g function. So I would plug in a 0, I would plug in 1.5, and I would plug in negative 1.5. And I would see which ones are going to be which function is largest there. So let's start with 0. When I plug f of 0 into the 0 into the f function, 0 goes in there and that gives me 0 here, 0 here, so it gives me 3. When I do that same thing with g of 0, I get negative 1. So it's clear that the f function is larger than the g function at this point in time. And if we go ahead and look at our ways that we integrate, we know that we're going to have f of x, if f of x is greater than or equal to g of x throughout AB, meaning they're continuous, then we're going to take the largest function minus the smallest function, and we're going to integrate from basically root to root where they touch. Well, we're going to integrate then from negative 1 to 1, and we're going to take the f function, which is larger, which is x to the 4th minus 4x squared plus 3, and we're going to subtract out x squared minus 1. So I'm going to go ahead and write that up here and say that one of our integrals is going to be integral negative 1 to 1, and it will be the x to the 4th minus 4x squared plus 3 minus x squared minus 1 dx. This is going to be one of our integrations. Now, I want to check to see, when I plug in negative 1.5 into the f function here, I plug negative 1.5 in up here, I take negative 1.5 to the 4th power, I subtract out 4 times negative 1.5 squared, and I add 3. I get negative 0.9375. Now when I do the same thing with g of negative 1.5, I get negative 1.5 squared, so negative 1.5 squared, add or subtract the 1, I get 1.25. Now the g function is actually bigger than the f function for the negative 1.5. Now if I do the same thing for 1.5, if you notice that I'm plugging in the same values, right? Well, if I plug the same values into the quadratic, or I'm plugging in, the opposite, so opposite signed values into a quadratic, that's not going to change it. So g of 1.5 is still 1.25. Same thing with this 4th power polynomial. When I plug in the positive version, I have even powers. That's going to leave this the exact same, negative 0.9375. So here, the g function's larger than the f function. So what does that mean? That means that when I do my subtraction of the functions, instead of doing the f function minus the g function, I want to do the g function minus the f function for our roots negative 2 to negative 1 and 1 to 2. So I'm also going to have to integrate from negative 2 to negative 1. This time I'm going to do x squared minus 1 minus x to the 4th minus 4x squared plus 3 dx. And I'm also going to integrate from 1 to 2 the same function, x squared minus 1 minus x to the 4th minus 4x squared plus 3 dx. And this is going to give me an area, this will give me an area, this will give me an area, and I'll add all those areas together, and that will be my area for the regions enclosed by those curves. So let's go ahead and do this. If I distribute here the negative x squared to the negative 1, this is going to give me integral negative 1 to 1. That would give me x to the 4th minus 4x squared plus 3 minus x squared plus 1, which I can say is x to the 4th minus 5x squared plus 4 dx. So I'm going to integrate this x to the fourth minus 5x squared plus 4, and that would equal x to the fifth over 5 minus 5x cubed over 3 plus 4x, and I'm evaluating this from -1 to 1. So when I plug those in, I end up with, well, 1 goes in here, or let's just plug it all in, it's fine. 1 goes in, and I get 1/5. That's pretty easy to do. 1 goes in here, 1 cubed is 1, so I get -5/3. Plug in 1 here, I get 4. And then minus, I'm just going to get the negative versions when I plug those in of what I just got. So I'm going to get -1/5. Plug in -1 here. I'm going to get +5/3. And then -4. And all that's going to equal, plug all that in the calculator. So if I plug it all in the calculator, so alpha, I get 1/5 minus 5/3 plus 4 minus -1/5 plus 5/3 minus 4, which is 76 over 15. So one of my areas is 76 over 15. Hopefully you can see that. It's not written that well. I'm going to write it here. 76 over 15. So now I can do the integration for this one. Now I'm going to kind of skip a step here just so I can save myself some room. I'm going to get the integral -2, -1. When I distribute the negative to x to the fourth, I'll write that as -x to the fourth. Distribute the negative to the -4x squared, that's +4x squared. I already have 1, so that's going to be +5x squared. And then I distribute the negative to the 3, this negative to the 3, that's -3 and -1, which is -4 dx. When I do the integration for that, that's going to equal, let's go, -x to the fifth over 5 plus 5x cubed over 3 minus 4x, evaluating it from -2 to -1. Plug those in. I plug in -1, and that's going to give me -1 times a negative, which is +1/5. -1 goes in here. That gives you -1 when you do the cube of that, so you get -5/3. Plug in -1 here, you get +4. Minus, plug in -2, and you get -2 to the fifth, which is -32. -32 times negative is +32 over 5. -2 to the third power is -8. Times 5 is -40 over 3. And -2 times -4 is +8. Let's plug all that in the calculator. So we get 1/5 minus 5/3 plus 4 minus 32 over 5 minus 40 over 3 plus 8. 22 over 15. So we have 22 over 15 for the area there. Finally, we're going to do the last integration here. Now, this integration is the exact same as the previous integration. So I'm going to skip a step and say that I'm going to take this part right here because that's exactly what you do when you integrate here. Nothing different, right? So we're going to say that this is equal to negative x to the 5th over 5 plus 5x cubed over 3 minus 4x, but we're evaluating this from 1 to 2. Okay, we plug those in, and this is going to be negative 2 to the 5th is 32 over 5. 2 cubed is going to be 8, so we end up with plus 40 over 3 minus 8. Minus, I plug in 1, I get negative 1/5 plus 5/3 minus 4. If I plug all that in the calculator, I get negative 32 over 5 plus 40 over 3 minus 8 minus negative 1 over 5 plus 5/3 minus 4. 22 over 15. Now this should make sense. I didn't say this before, but we have a 4th degree and a 2nd degree. Those are just symmetrical across the that y-axis. So these two areas should have been the same. Now let's go ahead and say that the total area then is 76 over 15 plus 22 over 15 plus 22 over 15. If you add those up, that's 120 over 15, which is 8. So our area between the two curves for those 3 little areas that we saw in that graph, so the areas in here, negative 2 to negative 1, negative 1 to 1, and 1 to 2, our total area there is 8.